A wall calendar always looks neat and orderly. 365 little squares, divided evenly into 12 months, with each day assigned its own clear position. The solar system, however, does not operate that way. Earth does not complete one orbit around the sun in exactly 365 days. It takes about 365.2422 days. That small remainder, not even a full quarter of a day, does not seem impressive when viewed on its own. Yet, as it accumulates year after year, it begins to shift the entire calendar that human beings rely on to organize life. This drift is not just a matter of paperwork. If each year falls short by about a quarter of a day, then, after 4 years, the calendar will lag by nearly a full day. Compared with Earth's actual position in its orbit, after a century, that error would be large enough for winter on the calendar to begin sliding into November, while spring would appear on paper when the trees outside were still bare. A calendar created to anticipate seasons and weather patterns would completely lose its function. If it were not corrected, at first, people tried the simplest solution. Every 4 years, they added one extra day and called it a leap year. That rule dates back to ancient Rome. When Julius Caesar reformed the calendar and created the Julian calendar, for the first few centuries, the system worked fairly well. The problem was that a Julian calendar year is about 11 minutes longer than the true astronomical year. 11 minutes sounds trivial, but when added up year after year, it means the calendar slips by another full day, roughly every 128 years. By the 16th century, the mismatch had reached 10 days. Enough to make religious holidays fall out of sync with the seasons they were meant to represent. At that point, the issue was no longer academic. Religious observances, harvest cycles, and agricultural taxes all depended on the calendar. Pope Gregory XIII then asked a group of mathematicians and astronomers to redesign the system. The result was the Gregorian calendar, essentially a software patch for time itself. They kept the rule of adding a day every 4 years, but introduced another condition. Years divisible by 100 would not be leap years, unless they were also divisible by 400. It sounds less like a social convention and more like a line of code. And in practice, it works exactly like an algorithm. This rule reduces the error to an extremely small level. On average, a Gregorian calendar year is about 365.242 days long, which comes remarkably close to Earth's real cycle. The remaining drift is only about 26 seconds per year, meaning it would take more than 3,000 years to accumulate into a single day of error. On the scale of a human lifetime, the system is nearly perfect. Yet the most striking part is not its precision. It is the way human beings forced nature to fit a mathematical structure. Earth continues along its orbit at the same pace, neither faster nor slower. The calendar is the interface layer humans placed over that motion. If that interface drifts out of alignment, every system that depends on it begins to drift as well. Put this into a more modern framework. GPS satellites do not only need to know where they are in space, they also need to synchronize time with precision down to fractions of a billionth of a second. A tiny clock error can produce a position error of several meters on a map. If calendars and timekeeping systems were not standardized, each signal station would effectively believe it was operating at a different moment. At that point, a navigation device would stop being a guidance tool and become a machine for generating mistakes. Financial exchanges operate in much the same way, relying on timestamps accurate to the millisecond. A buy order and a sell order may be decided by nothing more than that minuscule difference. If two systems are not synchronized in time, the order of transactions can be reversed. That would not merely create a technical glitch. It would also open the door to market manipulation. So a calendar is not just a tool for knowing what day it is. It is a shared standard, a kind of foundational operating system for every structure that depends on time. When you look at New Year's Day, you are not witnessing the moment Earth begins a brand new natural cycle. You are looking at a reference point, chosen by human beings, after they adjusted, trimmed, and synchronized a motion that has never cared about our convenience in the first place. There is one small detail that often goes unnoticed. Leap Day is not an arbitrary addition. It is a DEBT payment made in installments. Each year, the calendar owes reality about a quarter of a day. February 29th is the moment the system pays back that debt, keeping everything from drifting too far out of place. Without that payment, the error would quietly build until it became large enough to expose the mismatch. However, if you think Pope Gregory's patch was the final word on the matter, the reality is far more restless. Earth is not a perfect metronome. It is a dynamic, living entity. Influenced by the tidal tug of the moon, the shifting of magma deep within the mantle, and even massive earthquakes that subtly redistribute the planet's mass. The result is that Earth's rotation is gradually slowing down. A day today is a few milliseconds longer than a day was during the age of the dinosaurs. To compensate for this celestial procrastination, scientists had to introduce a concept even more granular than the leap year: the leap second. Since 1972, we have occasionally inserted an extra second at the end of June or December. It is a brief tap on the brakes of the digital world, allowing the silicon clock to wait for the physical world to catch up. If the leap year prevents the seasons from drifting over centuries, the leap second prevents our satellites and global networks from falling out of sync in a heartbeat. It is a reminder that as we advance further into the technological age, the price of precision only becomes steeper. The micro cracks in the clockwork. However, if you think Pope Gregory's patch was the final word on the matter, the reality is far more restless. Earth is not a perfect metronome. It is a dynamic, living entity, influenced by the tidal tug of the moon, the shifting of magma deep within the mantle, and even massive earthquakes that subtly redistribute the planet's mass. The result is that Earth's rotation is gradually slowing down. A day today is a few milliseconds longer than a day was during the age of the dinosaurs. To compensate for this celestial procrastination, scientists had to introduce a concept even more granular than the leap year: the leap second. Since 1972, we have occasionally inserted an extra second at the end of June or December. It is a brief tap on the brakes of the digital world, allowing the silicon clock to wait for the physical world to catch up. If the leap year prevents the seasons from drifting over centuries, the leap second prevents our satellites and global networks from falling out of sync in a heartbeat. It is a reminder that, as we advance further into the technological age, the price of precision only becomes steeper. Time as invisible infrastructure. In the modern era, time has migrated from an abstract philosophical concept to a vital form of invisible infrastructure. Consider the national power grid, or a 5G telecommunications network. For these systems to transmit data at the speed of light without collision, they require a shared, absolute pulse. If cell towers are out of PHASE by even a millionth of a second, the flow of information becomes congested. Calls drop, and data dissolves into meaningless noise. We are living in a crystal palace built upon tiny decimal points. Every time you use your phone to hail a ride or process a payment, you are unknowingly utilizing the fruit of millennia of stargazing. And the most sophisticated time adjustment algorithms ever devised. Why do we obsess over correcting these microscopic discrepancies? The answer lies in the very definition of civilization. Civilization is the sustained effort to create order out of chaos. By creating the calendar, We transformed the aimless flow of time into a road with lanes, signs, and milestones, accepting the 0.2422 discrepancy, and finding a way to fix it, is not just a math problem. It is a statement of our place in the cosmos. We are not merely organisms drifting with the seasons. We are active observers, capable of negotiating with the universe to build a stable society. Every time a calendar page turns, or your phone clock updates automatically, you are witnessing a massive legacy of persistence. It is the echo of Roman priests, Renaissance astronomers, and modern software engineers. We are still writing the patch for time, second by second, day by day. It is because of these tiny installments of debt repayment that our world does not slide off its tracks literally or figuratively. The order you see on a wall calendar is not a gift from nature. It is a masterpiece of compromise that humanity has collectively maintained for thousands of years.